He is known as the greatest mathematician of antiquity. He has a day dedicated to him called the Pi Day. He is the father of mathematics and mathematical physics. Who is he? Today, I am going to be sharing a story on Archimedes of Syracuse. Born on 287 BC in Syracuse, Sicily, Archimedes resided for most of his life in Syracuse. It is highly likely that when he was a young man, Archimedes studied in Alexandria, Egypt. This was substantiated through various compelling proofs, such as he knew personally a well-respected astronomer and mathematician at Alexandria, Conon of Samos, and regarded him both very highly for his abilities as a mathematician and also as a close friend. In addition, he is also friends with Eratosthenes of Cyrene, who was the head of the Library of Alexandria and a polymath who first calculated the circumference of the earth. Archimedes gained a reputation due to the inventions of machines which were used as engines of war when Syracuse was attacked by the Romans under the command of Marcus Claudius Marcellus. Archimedes was said to have written quite a number of works throughout his life. I will be sharing about his 9 extant treatises, labeled in the chronological order suggested by Sir Thomas Littleheath in his book, A History of Greek Mathematicians II. On the sphere and cylinder, his pivotal discoveries centered around establishing the relationship between a sphere and a cylinder. Initially, he discerned the correlation among a sphere, a cone, and a cylinder, all sharing identical dimensions in terms of radius and height. According to Archimedes, the sum of a cross-section on a sphere and a double-napped cone is equal to the cross-section on a cylinder, given that they are cut at the same horizontal line. He proved this by illustrating that the water level in a container, when the cylinder was submerged, equaled that when the sphere and the double-napped cone were immersed. This shows that their volume is equal. He knows that the volume of a cylinder is 2 pi r cubed, and the volume of a cone is 1/3 of that. From here, he obtained the formula to calculate the volume of a sphere, which is 4/3 pi r cubed, 2/3 the volume of a cylinder. In the treatise Measurement of a Circle, Archimedes found the exact value of pi using the method of exhaustion. How? Like this. Take a circle, inscribe it with a polygon. Next, increase the number of sides repeatedly. A square, a pentagon, hexagon, and octagon. We can see that as the number of sides increase, the polygon becomes more and more similar to the circle. Now back to the circle, give it a radius of 1/2. We know that the formula for the circumference of a circle is 2 pi r. Substituting r with 1/2, we get pi. Now we know that a circle of radius 1/2 has a circumference of pi. But what is the value of pi? In this diagram, we can obtain the equation sin theta equals to 2a by using trigonometry. We can also see that the length of one side of the polygon inscribed on the circle is 2a. Hence, length of one side is equal to sin theta. To calculate the perimeter of the polygon, we use the formula n times sin theta. A complete circle has an angle of 360 degrees. Since the angle theta uses only half the length of one side, we can divide 360 over 2n to get theta. Simplifying the equation, Archimedes managed to find that the perimeter of a polygon inscribed on a circle is n times sine of 180 over n. If we try substituting n with 97, we will get the value 3.141592653, which is the value of pi. In the treatise on plane equilibriums, Archimedes explains the fundamental principles of mechanics. This includes the law of lever and center of gravity of plane figures. To demonstrate, take a lever and put a weight on both ends. If the weight is the same and the distance from the weight to the fulcrum is also the same, the lever will be balanced. Now, what will happen if the weight on one end is twice the weight on the other end? Let's say 60 kg versus 30 kg. How do we balance the lever? This can be done by moving the ends with more weight closer to the fulcrum. Archimedes said that as long as the amount of weight times with the distance between weight and fulcrum for both sides of the lever is the same, the lever will be balanced. Next, his findings on the center of gravity of plane figures can be demonstrated on a triangle. Let point X be the center of gravity of this triangle. If you draw a line from the corner of the triangle across point X, you will find that each line has a length of 2/3 and 1/3. In the sand reckoner, Archimedes finds the number of grains of sand which could be fitted into the universe. His mission was to show how to calculate with what were previously considered an impossibly large number by creating a place value system of notation with a base of 100 million, which is myriad, where a myriad represents 10,000. Archimedes estimated that the number of sand that would fit the universe is 8 times 10 to the power of 63. This treatise also helps preserve the heliocentric model proposed by the astronomer Aristarchus of Samos, who was said has worked with his father Phidias. In order for Archimedes to find the number of sand, he needed to know the size of the universe, which he refers to the findings of Aristarchus on the heliocentric model. In treatise number 7, Quadrature of the Parabola, Archimedes found that the area of any segment of a parabola is 4/3 of the area of the triangle, having the same base and height as that segment. To illustrate, take a parabola and draw a triangle on it. Make sure that the base and the height is the same. Now, extend the triangle into one with twice its size by doubling the height, still the same base. Next, go even crazier and draw another triangle of height 4 times the original one, but keep the base the same, making this yellow triangle 4 times the size of the original triangle. Archimedes wants to find the ratio of the area of the yellow triangle and the parabolic segment. First, he draws a line from one corner of the yellow triangle across the center of gravity and extend the line to create a lever. Using a very heuristic method, Archimedes discovered that the lever achieves balance when the distance from the parabolic segment to the fulcrum is 3 times that of the triangle to the fulcrum. From there, he found that the triangle and the parabolic segment has a weight of ratio 3:1, meaning the ratio of this green triangle from before and the parabolic segment is 1 to 1/2, meaning that the ratio of the original triangle and the parabolic segment is 1 to 3/4, giving the formula area of parabolic segment equals to 4/3 of the area of the triangle. Treatise 8 on floating bodies talks about a well-known principle, the Archimedes principle. Archimedes said that an object placed in a body of water will float due to an upward force called the buoyant force. The amount of force is equivalent to the weight of the fluid the object displaces. It is said that Archimedes arrived at his conclusions in trying to work out how a ship as large as the Syracusia will be able to float. There are 3 more treatises that I will not be sharing much on, which is Treatise 3 on conoids and spheroids, Treatise 4 on spirals, and Treatise 9, the method of mechanical theorems, where he described the way in which he discovered many of his geometrical results. There are a few other discoveries that Archimedes was said to have made, including some of his famous war machines, the claw of Archimedes, which is a crane-like mechanism that would swing down and either capsize the ship or pick it up to dash it into another, a heat ray, which is a set of mirrors that focus sunlight on enemy's ship, setting them on fire. Next is the Archimedes screw, a device where one end is placed in water, elevated at an angle and turned, trapping the water in air pockets, rising them from the lower end through the open upper end. This device is still widely used nowadays, for example in amusement parks and in pumping stations. Next is the story of Eureka, where Archimedes was said were tasked to find out if the king's crown was truly made fully by gold, or has the artisan lied and stole some of the gold, replacing it with silver. Legend has it, he discovered his principle of buoyancy while taking a bath. He noticed the water rose as it was displaced by his body and understood this principle could be used in establishing the density of the crown. He was said to have become so excited at this revelation that he ran out of his house down the street without getting dressed, yelling Eureka, an ancient Greek word meaning I have found it. Last but not least, Archimedes' observations of solstice that were used by Hipparchus, the foremost ancient astronomer. Archimedes was killed when Syracuse eventually fell to the Romans in 212 BC in the Second Punic War after all his efforts to keep the Romans at bay with his machines of war had failed. Archimedes was said were engaged in some calculations involving a diagram when he was approached by a Roman soldier who commanded him to follow him to Marcellus, as Marcellus has gave strict orders that Archimedes was to be taken alive and considered him a military asset. Archimedes was so deeply engaged with whatever he was doing, he allegedly told the man, "Do not disturb my circles." Against the order of the Roman general, the soldier drew his sword and killed him. Some said that the soldier did not recognize him, but there were also theories that mentioned the soldier knew who he was and killed him to avenge the many Romans who had died from his inventions. Either way, Archimedes died in the hands of the Roman soldier. That is the end of the story on one of the greatest minds in history, Archimedes of Syracuse.